processing and storage capacities of modern handheld devices is greater than ever. In some cases, these machines exceed what could be done with desktop PCs 10 years ago. However, the limited output and limited input of these devices prevent them from accomplishing many of the tasks that common desktop users need. We have developed the XICE Framework to alleviate this problem. XICE accomplishes this by allowing handheld devices to annex rich output and rich input when convenient for the user. Now applications run on the handheld but can be used on the desktop, projector, wall screen, television, or any other appropriately configured display. Our prototype handheld is the Sony Vaio UX, a little bigger than normal handhelds but much easier to program. This is a powerful spreadsheet application, but with 3 columns of output and stylus-based input, this is not a very satisfying experience. To alleviate this problem, we're going to push this UI to a much larger screen that also has a full keyboard and mouse. Once the spreadsheet's on the display's input can be used to resize, reposition, and interact with the data normally. VGA cannot handle 3 screens with so many pixels, so we push the UI from this handheld across the internet via Wi-Fi to the screens. Keyboard and mouse input are sent back to the handheld where they're processed by the application. Changes to the UI are automatically sent back to the screen. Here we're going to give a presentation on a projector in a conference room. To do that, we first must pick the projector we're going to give this presentation on, and then when we're ready, we can start up the presentation. This projector doesn't provide any input for us, so we must get it through the handheld. The user advances the slides through the handheld where the entire presentation is running. Some screens do not provide input, or the user may not trust its input. To help with this, we have augmented our handheld device by attaching the guts of an optical mouse to the back of it. Now we can have an entire self-contained mouse and computer. We call this the MousePuter. We're pushing this spreadsheet to a display whose input we do not trust. Afterwards, we push several other applications by tapping a single button in their title bars. Now the user can rearrange the windows and interact with the applications as though they're using a normal mouse. But they can do this confidently because all the input and all the processing happens within their MousePuter. This is a new display in a classroom that we want to annex. This display clearly posts the information necessary to connect to it. This is some code that the user would like to show on that display. So they create a new connection, enter in the information necessary to connect, and then push their data up onto that display. Now that their code is on the public display, the user can resize it however they'd like, and then they can select, edit, and scroll through their data as though it's on a normal screen. This screen doesn't provide any text input, so it must come by way of the stylus through the handheld. Consequently, the user is going to constantly look back between the handheld and the screen to double check their input. To prevent this, we duplicate the application's window on the handheld. This way the user can type text directly and see it update immediately. The UI code for these 2 windows is separate, but through Model View Controller design, both windows show the same updates. We have demonstrated the XICE framework, which allows applications to provide rich output and accept rich input, even though the applications run entirely on handheld devices. The MousePuter is a special handheld device that has an optical mouse embedded in the backside of it. This device now can provide input on screens that either don't have input or the user does not trust. Untrusted input is any the user thinks could be malicious. The XICE framework can be used to let applications on small handheld devices annex screens in a wide variety of places, including on the ceiling.